3, we are going to attempt to do the most difficult solving problem by completing the square. And it's the equation you see in front of you. There's no numbers, all variables. A, B, and C can be whatever they want. So what we're going to do is by completing the square, we're going to create what is known as the quadratic formula. So as we remember from the previous video, A and C had to be removed right away. So we're going to get rid of A and C, divide over the A, just like we divided over the 2 and the 3 and the 4 that we've had before. Yes, that's going to leave us fractions, but don't panic. We'll take our time here. This C over A is technically our constant, which we are going to subtract to the other side. And as we do this, we're going to put in our plus blanks. And again, leave yourself some space here after that first fraction because we need to guarantee that this denominator is going to be a perfect square. All right, so to fill in our blanks, we go to B over A. And if you recall, we're going to take half of that, which means just multiply the denominator by 2. So plus B over 2A, we're going to square that. That's going to give me a B squared over 2 squared, which is 4A squared over, wait a minute, that's a perfect square in this denominator. All right, so we want to make this denominator A to look just like this denominator. So we're going to need to multiply by one more A and the 4 to the top and the bottom of this first fraction. In doing that, we'll be able to simplify this to one fraction. And what I did is I noticed that I had a negative C times 4A, so I opted to make that second as minus 4AC, and I put my positive B squared up in front. So I just rearranged those two terms. But there's my denominator, 4A squared. And over on the left, the x squared, x goes into the parentheses, the plus b over 2a goes into our parentheses squared. Now we are down to technically one variable term x here. So again, recall to solve this, we're going to then take the square root of both sides. The denominator, you will be able to take the square root of that. The square root of 4 is 2, the square root of a squared is a. The top, you cannot simplify. Even though you have a b squared here, there's this minus 4ac. This is two separate terms, one big binomial, if you will. And if it's a binomial, you either have to take the square root of the whole thing or nothing at all. Over here, we're out inside of our parentheses now. We can subtract over the b over 2a, sneak that in front of the plus or minus, and this is the quadratic formula. Now, you may have seen this before, but you've seen it as one fraction, and most book publishers prefer to write this as one fraction, and that is wrong. Trust me, it's going to save you points by learning this as two fractions, and I'll explain that when we look at examples, why you want to look at this as two fractions. All right, so let's take our quadratic formula and let's go work on some examples here. I have 4x squared minus 6x minus 9 is equal to 0. There are 4 times 9, that's 36. There are no two numbers that multiply to be 36 that add or subtract to be a negative 6. So we want the quadratic formula. So identify the a, that's the 4. Identify the b, take the sign, negative 6. Identify the c, that's negative 9. We're going to substitute everything into our quadratic formula. So a negative, now your b is a negative 6, 2 times a, which is 4, so this denominator over here will be 2 times 4 as well. And then I have my 6 squared. You don't have to put the negative 6 in here to be squared because you're going to square it, which makes it positive anyhow. So we don't need the negative here. Minus the 4 times the 4 for the a times the c, which is negative 9. All right, so now what we want to do is we want to start to look at simplifying. Since these are two separate fractions, I noticed, wait a minute, this 2 can go into that 6 3 times. And my two negative signs, negative times a negative, will become a positive. Now, the reason why this is important is that if this fraction can reduce 99% of the time, then the second fraction is going to reduce. So therefore, we're probably going to want to work this off to the side to simplify this radical to see what we can cancel. So make my two negatives a positive. 2 goes into 6 3 times. I now have 3/4 plus or minus. Like I said, we're going to take this big radical and we're going to simplify it. So I'm going to go to my calculator, type in 6 squared minus 4 times 4 times negative 9. That's 180. We're going to put 180 inside of our radical. And now we want to start to take out a perfect square. So since this ends in a 0, I could go 18 and 10, but neither one's a perfect square. If I were to divide this by 5, 180 divided by 5 is 36. This is a perfect square. So the square root of 36 is going to be 6, and the 5 will stay on the inside. There's my 6 times 6 squared that I can take out of the square root. And now we put that up in the numerator. And like I said, since we were able to simplify this fraction, this 2 can go into that 6 3 times. And there's our simplified answer. Okay? All right. Next problem. Let's see, I want to get my calculator out for this one as well. I want to show you a calculator trick here. Okay, so here A is 3, B is -5, and C is 7. We're going to enter these into our formula just like we did over here. So negative 5 on the top, 2 times 3 on the bottom, plus or minus. Again, notice the B always goes in as positive. 5 squared minus 4 times 3 times 7. Keep that same 2 over 3. Now, in this case, the only thing I can simplify are the two negatives, which makes that a positive. That's not considered reducing. But the 2 nor the 3 can cancel into the 5. So I am going to simplify these 3 parts of my fractions. Now, just like we said over here, if the first fraction reduces, 99% of the time the second one is going to reduce. Well, that works in reverse. If the first fraction doesn't simplify, 99% of the time, neither will the second one. So we're just going to go simplify 5 squared minus 4 times 3 times 7. So enter that into your calculator. We get a -59. So in square root of a -59, all we can do is take out the I. 59 is a prime number. Nothing's going to cancel. That's your answer. All right. Now, what the authors like to do is they like to take these equations and make them more difficult. So for example, here we have to simplify away the parentheses and set it equal to 0. So we got to turn this into ax squared plus bx plus c equals 0. So you distribute the x squared plus 5x, distribute the 2. 2 times 2x is 4x times the -1 minus 2. You want to keep the x squared positive. So we're going to move the 4x over to the left, and we're going to move the -2 by adding 2 over to the right. So we can only combine our x terms to get x squared plus 1x plus 2 equals 0. There are no two numbers that multiply to be 2 and add up to be 1. So we're going to use our quadratic formula here. A is 1, B is 1, C is 2. We'll substitute them into our formula. 2 times 1 is 2. Nothing's really going to cancel here, so this will stay -1/2. Put the 2 down here. So again, first fraction didn't reduce. Excuse me. Second one will not reduce. So we're just going to go to the calculator, crunch the numbers here. 1 squared, well, wait a minute, these are small numbers. We can do this. 1, 4 times 2 is 8. 1 minus 8 is negative 7. The negative comes out as an I. So there is my final answer. Now over here, we have our x's in the denominator. And here, x can divide evenly into x squared. So this x squared is your least common denominator. And what I want to do is multiply that to every single term. So 2 gets multiplied to the x squared. The 7 over x gets multiplied by x squared. The 4 over x squared gets multiplied to x squared. Even the 0 gets multiplied by x squared. But we know if we multiply by 0, that will stay 0. And then on the left side, x squareds will cancel. 1x will cancel with one of these x's up here. So this x is going to leave us a 7x. And now we have 2x squared plus 7x minus 4 equals 0. Now we're in the format that we want. So basically what the author did is take this equation and divided everybody by an x squared and made this new equation. So using our quadratic formula, a is going to be 2, b is going to be 7, c is going to be negative 4. We plug it into the values. Negative, put in the 7, 2 times the 2, 2 times the 2 over here. 7 squared minus 4 times 2 times negative 4. So we're going to get no reducing. So there'll be no reducing over here. Go to our calculator, find 7 squared minus 4 times 2 times negative 4 is 8. Wait a minute, 81. Square root of 81 is 9. The square root symbol disappeared, so we're going to put a 9 here. Now remember what we said in completing the square, that if the square root disappears, you have to write 2 equations. So our first one will be x equals negative 7 fourths plus the 9 fourths, which we now can add together because my denominators are the same. Negative 7 plus 9 is 2. 2 fourths is 1 half. So one of my answers is 1 half. Then we'll do negative 7 fourths minus the 9 fourths. Negative 7 minus 9 is negative 16. 16 divided by 4 is 4. So negative 4 is my second answer. All right. Now, another thing you can do with the quadratic formula is you can write, not to say a program, but you can, because you're going to do a lot of these problems over and over and over again, you could store the A value, the B value, and the C value. And what we can do is you can type in this part right here every single time. The B squared minus 4AC, just have your calculator crunch the numbers. And that way, if you store B, you don't have to worry if it's a negative or a positive. That way you don't make a calculator error. All right, well, speaking of B squared minus 4AC, that is called your discriminant. This is the part of the problem that really determines what kind of answers you're going to have. So the determinant is going to determine, the discriminant is going to determine how many solutions there are and what types of numbers they're going to be. So you can have 1 or 2 answers, and your numbers are going to either be rational, that means they're all fractions with no square roots in them. Irrational will mean that you will have a square root left over in that second fraction. Or imaginary, you're going to have an I as part of your answer in that second fraction. So what we have to do is we have to simply evaluate this. So that's why I said you might want to store the A, store the B, store the C, and have your calculator just do alpha B squared minus 4 times alpha A times alpha C. And you don't even have to put the times symbols in between. But if this discriminant is less than 0, which means it's negative, you automatically will have 2 imaginary solutions because you're taking out an I because there's a negative value inside your square root. Remember, this is what's inside the square root symbol. If your B squared minus 4AC is equal to 0, well, the square root of 0 is 0, then the numerator is 0, so that second fraction 0, you won't be adding or subtracting anything, So you will have one rational solution. In fact, that answer is the negative b over 2a. And then we got a little bigger section here, a bigger row here, if you will. B squared minus 4ac is greater than 0, which means it's positive. Now, when that happens, there's two cases. Case 1, your b squared minus 4ac value is going to be a perfect square. If that's the case, there will be no square root left over, and you'll have two rational solutions. No square roots in your answer. But if case 2, I'm not a perfect square, then I have two irrational solutions. Now the square root is still in your answer. So when we ask about the discriminants, you're really not solving for x. You're just going to tell me how many solutions there are and what kind of numbers they're going to be based on whatever number you get from b squared minus 4ac. And again, this should be calculator work that you should be punching into the calculator, write down your calculator entry, and write down the value you get. So for example, the question usually reads, for each equation, determine how many solutions, 1 or 2, and what type of numbers exist, rational, irrational, or imaginary. So all we need to do is calculate b squared minus 4ac. So a is 9, b is negative 12, c is 4. Again, this is where I go to my calculator, and you might want to think about storing 9 store alpha a, negative 12 store alpha b, 4 store alpha c, and just type in b squared minus 4ac into the calculator. All right, again, I don't need to put the negative there, so let's get rid of it. Or if I use the b squared minus 4ac, when I'm typing in those variables, I don't have to worry about the negative either. So here we let the calculator do the work. You will write this down on your test. You will tell me the answer equals 0. Based on 0, you have one rational solution. So I need to see this step, I need to see your answer you get, and then I need you to tell me the answer, or the how many answers and what type of numbers based on this value. So we got to make sure we type this into the calculator correctly. Over here, a is 1, b is 5, c is 8. We're going to type in 5 squared minus 4 times 1 times 8 into our calculator. We get a negative 7. So we'll put down equals negative 7. You have two imaginary solutions based on the negative 7. Next, we have a is 2, b is 7, c is negative 3. So 7 squared minus 4 times 2 times the negative 3. Calculator tells me that's 73. Now, if you get a number here that's so big and you're not sure if this positive number is a perfect square or not, literally take the square root of that number. If you get decimals, it's not a perfect square. If you get an integer, it's a perfect square. So 73 is not a perfect square. That's somewhere between 64 and 81. So this will be two irrational solutions based on that 73. So again, you're going to write this down, say equals 73, and then this is your conclusion based off of that number. Next, we have a is 6, b is 13, c is 6. So 13 squared minus 4 times 6 times 6. We'll enter that into the calculator. We get a 25, which I know is a perfect square. It's also, positive. So that's going to be two rational solutions because the square root symbol is going to simplify away. And that is our section 9.3.